Hello, hello. Happy Sunday. Happy Valentine's Day. If you celebrate that kind of thing. I do because it's my half. It's like it's a special day with me and my wife. It's not like our anniversary or anything. But still a nice day for us to hang out. So probably won't stream like all the way until 12. I mean if I can remember. So I can go make her lunch, and then we can have the rest of the day to ourselves. All right. Now let's see about what we're doing here today. Right. So we're working on an ECS system, and we were just continuously running into problems getting to be able to store the component data. And so we decided, we should probably just have the data be set up in some kind of enum, and then we can easily store that in our hash map of component enum. So we can have something like all the locations together, which are points or maybe vector 2s, something like that. So if we start with our flocking simulator, so let's see over here. If we go into our, where would it be? It would be our just LibreS for flocking. We can see that we're creating a bird mesh, and the first thing we want to be able to do is display that bird to the screen. And so we're trying to give it a location and a velocity. And so we're going to have an update system that's going to allow us to add the velocity to the location, and then the bird will move around. So my thought for this, oh, and Zilby's here. Let me turn that on. Okay, he was here. I have a heater behind the green screen. So he'd probably want to go hang out back there. I'll turn it back on when it comes over. I've got food to lure him over in case he wants to come hang out with us. So I'm thinking a vector 2 would be really awesome for this because it would allow us to just add these together. Now I could also just have our own points, and that would allow, like, we could just do our own adding together. Like the logic could be added to that. That's something that we could definitely do. I'm not exactly sure. I kind of like the idea of using vector 2s behind the scenes, because that's like something from maybe an algebra. It's a math library. It's a linear algebra library that's well tested. It's popular. It's got a lot of these methods on it, but I need to wrap it. So I need to wrap it in my own interface that is essentially abstracts away that API. So if we, I'm thinking the way that I would use this would be spawn entity with component. We have to tell it that it's going to be a location. So it's going to be something like the string location, and then the what would it be? It would be an actual component, like an enum that we grabbed from something else. So it would be something like components vector 2. Now this would be an enum, right? So like vector 2 wouldn't necessarily be like a method on its own. Maybe it's like a tuple, or maybe like it's a struct on itself. I want to actually play around a little bit with enums, because like maybe there's something with advanced enums. Maybe there's something we can do with that. So like we can just do the variants like that. We can do variance, but then this is a tuple type. And then we can do a variant with a struct. And of course, an empty enum. Okay, so this could be a struct inside of here. So I could create a vector2 of my own to put into here. So that would make sense. So let's head back in. So we know that we want it to be some kind of like vector2. And then this would be like the new vector2 inside of here. Let's head into BP ECS. We know we have some problems in here. We're gonna have to refactor that away. Let's start by inside of source, because I don't want this in the world. I want, like, in case I need to abstract this entire type system away, components into its own library, if I just put it in here, then I'll be much happier. And on top of that, I think I might want to have like a folder system for it. Like, so components. Then we'll have a mod. So we'll do a pub mod components. And that allows us to now start playing around with this a little bit. So we can have a pub enum component. And let's say I want something like a vector2. And this is going to have to then be essentially a vector2. So we're going to have to pull that in somehow. So we can put a new file in here for a vector2.rs. This is probably going to have to be public. So pub mod vector2. And so we know that we care about like an X, which is an F32, and a Y, which is an F32. Now, in this case, that's what we care about. In the future, I might want to like make this more generic, so it's not just F32s, but it could be any of these types of numbers. And then you are going to store in a vector2 vector2. So that's what it's going to hold. It's going to hold this vector2. What I'm not sure how I want to do is, like, how do I want to create this, like to store it? So maybe I wonder if I need like a builder pattern for the component. So like tell it what it is, it chooses that thing, and then builds it out for me. And so all the methods for building the different types could be in there. I'm not sure. Because it's just like a single component right now. Let's play around with this. Okay, so let's test creating a component, a vector2. So how do I want this to look? So let's say we have like we want to be able to create this as like a location. So it's going to be, you know, 50.0, 25.0, something like that. So component, if we do vector 2, then inside of here, I would need to say vector 2, like that. Probably have my type separate. So the component is basically of a type, and the vector 2 then takes the vector 2. Yeah, interesting. I don't necessarily want to have this component be a... Yeah, I wouldn't want this component to just be like a location, because a velocity uses the exact same thing. So the velocity should follow this exactly. So then this would be like x 50.0, y 25.0, for example. And so this would be legal. I might want... Okay, what are you upset about? I need to save you. I wonder if I would want to abstract it. Okay, so if I have something like new, like component create vector, like what if I did something like this? So create vector 2, passed in like 50.0, 5.0. Then what we're going to return is a self. So it's going to be a component. But in this case, we know that it's a create vector 2. So we're going to return, so like let vector is equal to a vector 2 x and y, and then we're going to return that. Oh, it's private, so I can't set it like that. Oh, interesting. That could probably be public. I like this a little bit more. I feel like this is going to be a little bit easier to sort of like handle. So then to test this, we're going to assert equal I wonder if I can do the matches. Maybe we could just do assert. Oh wait, no, I think we ran into that we can't do matches in here like this. But let's try it anyways, because I can't remember for sure. So if I do our location and then we just create a vector 2 on our own. Okay, so we can't create a vector 2 on our own. This would be a component vector 2 vector 2 Yeah, I don't know how it's gonna like that. Okay, floating points cannot be used in patterns. I think I can use that because the variable doesn't exist, right? Oh, unused variable. Okay. Try ignoring the field. Oh, because it's... Oh, okay. So what if I just that? Heck, what if I just do that? No, okay, okay. So it needs this, but we can ignore what it is. So does that equal? So if I run this test, oh, okay. So we have to fix these. We have to fix our compiler errors in data. This is gonna be a pretty significant refactoring. So yeah, I probably don't even need you. Okay, you're not upset there. Flocking rest, you're upset. Right, because you don't exist yet. So let's just not do you for a second here. Okay. Okay, so that works. That works. I'm able to test that we created a vector2. I didn't necessarily test that the location is correct. I suppose that we could do that. Wonder if we can do so an if let. It's gonna be a component vector2 is equal to our location. Then I want to assert equal that vector2. Probably want to just do an assert because then I could just do the and. So the vector2 dot x, what do you see yourself as? We don't know what you are. You're an unknown. So you're a component. Oh, it's not going to be component. It's going to be component vector2. Okay, there we go. Here we go. Now we have the vector2 dot x is equal to 50.0 and vector2 dot y is equal to 25.0. And strict comparison. Irrefutable if let pattern. How can I fix that? Like it has to be this one? Do you want me to use a match? I kind of want to build this just to see what, like if it has any suggestions. Wait a second, I'm in the wrong. CD into we'll build here. Okay, unused import debug. Oh. Oh, okay. Hold on. This is a problem with Clippy. It detects irrefutable patterns in if let and while let statements. Okay, so a let or a loop statement will suffice. So you're saying that I could not do the if, I could just do let component equals location, do a semicolon here. Oh, let, like, okay, I think, does that work? They, result equals that. So then I want these to be result.x. Now I'm not sure how to get that out then. Unless like I add a getter. I probably need a match statement to make that happy. So like I could do a match on location. And then the only thing, yeah, I'm missing the match arms. Then if I fill the match arms. Oh, okay, I get it. It's because there's only one component vector 2. Okay, got it. If I had multiple components in here, I think that's when it would just work out fine. So in this case, we have the vector 2. And in here, we're going to assert that the vector 2.x is equal to 0. Vector 2.y is equal to 25.0. Okay. And then as we add more tests, then we can throw that in there. Now we don't use the import anymore, which is actually really nice. That means that nobody else has to be aware of how the vectors are, like how the vector 2 is created, and I can like swap out to different libraries if I want to. And I suppose what that means is I don't even need this vector 2 here. We could now just use the analgebra library. So I want to make sure I find the right one. Okay, yeah, this I believe is the correct one. So let's grab its name. Okay, so we've added 0.24.1. Okay, that is the correct version. So now that I have an algebra in, instead of this used in the self vector 2, we can use an well, okay, fine. You are going to be a vector 2. I thought you were going to memorize that. Oh, okay, hold on. Let's not grab that in. Let's actually just delete you. We don't need you anymore. And I wonder if I'd have to tell it what type it was too. Oh, I think cargo check is running. Do I have to tell rest analyzer to rebuild? Did it come into the right cargo toml? Yeah, it did. Okay, so here's that. It doesn't know how to find it. I have to restart rest analyzer. Okay, you're all restarted and happy. Let's try this again. Here it is. Okay. In algebra 2, this is going to be an F32. Like that. Okay, so then when we create the vector, we take in the x and a y, which is an F32. We let vector equals... So I can remove you. We're going to self vector 2 and to a vector 2 new x and y and return that. And so now that wraps around it and we can get this out. I'm not 100% convinced that I should, that this is like the best idea to do. I might still want like a wrapping struct around the vector 2 type from NAlgebra so that I can, like in case they ever change anything, I'll be fine. But I'm not really sure like architecturally if that's like the best idea to do either. Like, I don't know. Okay, so our test should still run. It should still be fine here. We do have to compile and bring in an algebra though. So how is this going to work? We're going to have components like I actually think, I don't know if we're going to need any more components besides a vector 2 for the flocking simulation, because our location and our velocity are both going to be, well, just, yeah, they're just both going to be the vector 2 with different names. So this is where it's going to be slightly different. So we're going to have this data new. I wonder if I want Letnam, hello. The assert could be assert matches location, component vector 2, v. If, oh, interesting. Okay, so basically like combine them all together. Let's try that. I haven't played around with matches too much. Just sort of like the basics. Because this way, if you return some other variant, the test will still pass. Oh, yeah, that's a really good point. So let's try this. I'm gonna comment you out. So let's do going to assert macro. Inside of the assert macro, then we're going to do the matches macro. Inside of the matches macro, we're going to pass it in. Okay, we're going to have our location as the first variant. And then our second one is going to be the component vector 2. And then this is going to be like just a vector 2. if vector2 dot x is equal to 50.0 and vector2 dot y is equal to 25.0. Yeah, okay, I like this. This looks a little bit better. Perfect. And so ways we could maybe make this a little bit better. I don't know. I think this is fine as it is for right now. So I can get rid of you. Yeah, I like this. I like this a lot. Thank you, Lena. Okay, so back into here. Basically, we want our data, which is really just the components. So a wrapper around, like we have a component. And then we have like the storage for the components, which really is like the data, right? Now in here, we have the hash map. I'm thinking for the type ID, this is going to have to become a string. And then inside of here, we're going to have a vector of a component. Debug. Okay, so we have to make sure that component implements debug. Okay, so that makes you happy here. Now, we have a bunch of tests and other problems here. Hey, Chantilly Cake, hello. How are you doing? Pretty good, awesome. That's great to hear. Let's see. So now we're gonna have our data stored like this. Now, I'm not convinced that this is a good idea. Yeah, like I think we may run into problems with the queries in the systems, and we may still have to use ref cells with cells, or RC with like a cell or a ref cell. We'll find out. Okay, so moving on, we create a new data. This is fine. When we insert, we take a new data. This doesn't need to be implementing of anything anymore. At this point in time, like I don't need to get like the new data type ID. It's just gonna be, well, I guess like when we insert, find out like what our, this is a vector of components. Right, okay, so self-data data entry, our key. So insert into here, we do have to have the component type. So really it's gonna be like the entity, which is we should actually have this be a str. So our key here is gonna be the entity. We'll just make this entity name. So that'll make that happier. Mismatch types, expected string. So string in this case will then, oh, I was hoping that, okay. I don't think that I can tell the hash map to take a stir. I don't think I can tell it to take like a static string either. Static stir. And I certainly can't tell it that it's like a str like this, it feels sad that I would have to take this query, make you a string, and then take this entire entity name ownership is fine with this? I thought it needed a oh, it does take ownership of it. Oh, okay, hold on, never mind. I thought it needed a reference to it, so I was gonna have to like convert back over. But I think what I can do is just say the entity name dot toOwned, which will convert it into a string, and then that'll be fine. And then or insert an empty vector, so that'll give us that. So regardless, we get the raw data out, which is a mutable reference to this vector, and then we're gonna push in the new data. So instead of this implementing anything, this is going to be a component. And instead of this RC fun stuff, this is just the new data. And then we're happy here. Then we have our query. Okay, so let's not worry about queries right now. So I don't think we're going to have a lot of, I think things are going to be a little bit easier. I don't even need any stuff. Okay, so create new data, assert, okay, that's fine. Insert data. All of this stuff that we're sort of like doing to get around that any is going to be a lot simpler. We create new data. We need to create a new component. So let's say like we create a location. So location equals a component, create a vector 2 with like 0. That gives us a component, data that inserts. Our entity name is going to be a location, and we're going to pass in the location. Okay, so then we need to get this, we need to grab this out to make sure that we've got what we expect to get. So it's going to be data.data.get, a reference to the name locations. That's just location. Unwrap 0, and then I think that's all I need to do at that point in time. I now have this component out. And then we can do the same sort of assert fun. Okay, so this is going to be our location, and raw data is the same. We also want to check that we can insert multiple datas. And so this is testing that, like, hey, we put 2 datas in here and we're getting the length of 2. So data insert. So these, we actually need like locations. Wait, that matches doesn't do anything here? What? Also, hello, Celinz. Or Celinz. Matches location, raw data. Oh, they're both components. Yeah, that's true. I need to make sure that location. Oh, actually. Second argument is always a pattern. Yeah, I guess, I wonder if I wanted to do a, I probably want to do raw data here. And then I want, okay, so then the pattern can be that it's a component vector2 if okay, I think that works. Or at least if it doesn't work, we'll find out later. Okay, let's see. Second one, we insert multiple data. We need 2 components. So we need 2 locations. So let location 1 equal to component create vector 2 at 0 at 0. Copy you can become like 10.0 20.0. You come location 2. Then we insert, okay, so this is going to be location and component 1. And another location with component 2. Right, because you're both location. Okay, so we insert this in twice. Then we get the components, which is you are just a location. Because I'm repeating that 3 times, let's just create, this is going to be the component name. Now I can just repeat you. No. Just you 3. We unwrap that. That gives us a reference to the vector, and then we check to make sure that your length is 2. So we have two in here. The first time I did this, I accidentally overwrote, so it was always a length of 0 or 1, which was not necessarily the great. And then let's just not worry about the queries for this second right now. Okay, so if I pull, let's like get rid of all these warnings. Need you. Don't need you. Because I think the queries are gonna have to be they're gonna be different. Get rid of all of you. All right, so then back to the world. Okay, so we have to fix this now. All right, so our first problem is when we query, well, let's just not do queries right this second. So we'll get rid of you. Sort of like going backwards a little bit before I go any. Yeah, so the problem was we're running into problems with getting mutable data and like querying. Yeah, downcasting and getting mutable was the problem. Now I can do it just fine if I'm getting immutable all the time. And that was fine. That was great. But I would probably, I mean, I might be able to do something like using arc and mutexes. Like that might work also. But yeah, it was just like a little bit too nasty. So I'm trying to find a different way. So that's what this is. That's why now we're going to go in from, instead of an any, we're just going to have components that this ECS knows about. It's not as like awesome as like some of the ECS systems like X or specs, but it's also only for like my game, so that should be fine too. Okay, so when we insert with component, we need the component name. So a name, which is going to be a stir like that. So we take in the name and then the component. Now, we're also not going to need this C anymore. We know that you're going to be an actual component. And so we put that in there, and then we return a mutable reference to self, so that we can continue to spawn as many components as, or add as many components as we want when we spawn an entity. Okay, so we need to change the documentation here too for usability. So each component is given a name, which will determine how it is stored. Data. The components are okay. So we could do that. Okay. So this means with component, we also don't need this here. Okay. So for test, we shouldn't need the any anymore. Okay, so create new world, we can create that, and data has a length of 0. Okay, that should be fine. We spawn an entity. Okay, so let's figure out like what this entity is going to be. We can like pretend that it's like a bird or something. So I'm actually thinking this might be a little bit simpler than what we have here. So we have this world, and then we want to do world dot spawn entity. Then dot with component, a location, so a component, a create vector 2, this would be like 10.0, 10.0, and like we can add in as many as we want. We can then do something like component, name is going to be like velocity, create a vector 2, and this could be something like 0.5, 0.3. So that spawns the entities into the world. Okay. Then to test to make sure that these spawned in, we can just check to see, hey, did we get the location in there? Like, is that in? And in this case, I believe that we should have, like, we're testing that like the spawn works. Our data should now have a length of 2, I believe. So I think we could just do this. Assert equal world.data.length is 2. I think this will work. Unless I have other compiler errors which we need to fix. I don't need that anymore. All right. Okay, fine. I can't get the length anymore because these components would need to implement copy and clone in order to do this. Interesting. I didn't know that. All right, let's we can just get one of the locations out. If I do a world dot data it would probably be best to have like a query, right? Like at this point in time, we should build a query out of here, and then that would be the test, right? We query for like all locations. So like, give me all the locations, and then I can like assert that, I don't know, like the first one is equal to this one, or the length of it. So let's actually have a to-do. And this is going to be query for locations and for velocities. Okay, so that will obviously be a problem once I when I run the tests again, but it'll at least allow me to not worry too much about this. Okay, so we don't need you. Let's fix all of these. I don't know if we're going to need that query struct anymore. I sort of have an idea that it's going to be simpler. Okay, so I think we're good here. Don't need you anymore. Okay, what are you yelling at me about? Okay, we need a default world. So this just runs data new. Can I implement a default world? No. Okay, fine. I'll make you happy, Clippy. We'll implement default for you. Okay, so for this we need to create a new world and return it. So that's going to be a self new, and that's it. Like that's all we needed to do to make this happy. And no more warnings here. Okay, so that's great. Now what are you yelling about? Cannot move out of here. Why did you suddenly pop up? So when we insert data, I don't want to. Okay, so data get. So hold on, what do we got here? It's an option. So I want to unwrap this. Oh, right. Okay, so it's a vector. It's a reference to a vector. I was hoping that I can get like the first one without just like getting that out. But I wonder if I could do this. Like I want the first one and I want it to be a reference. There we go. So now it's a reference to that component. And then we have the strict comparison on. Okay, perfect. Allow compare. There we go. And then you. Try this, and then nothing. Oh, interesting. Okay, or insert with. I guess it didn't like the new vector in this way. I wonder if it would be more happy with this if I just did a vec new. Like that. Oh no, because that's a function. Or default. Ooh, okay. Or default. Expected 0. Let's see. Will you? Okay. That's good. Thank you again, Silenzi, for that. That's a good one. I've never really thought about using or default, but I guess it is a vector, and I just want it to be an empty vector, so that would be the default. Okay, I don't think I have any more warnings in the BBECS side, so now we need to fix all the problems over in our flocking Rust. So over here in our world, okay, so let's and remove you. Just remove you. I'll bring them back. Okay, so drop param. Okay, so I want to create the, let's see, is there any more? No more problems here. Let's go to our systems. I actually we don't need to create the components in here anymore. So I can just go ahead and delete this. We'll be fine there. In our systems, let's not worry about the query right this second. So update locations, we're going to do that later. And our draw system, we're gonna do that in a little tiny bit. So we're probably gonna need to redo this a little bit. So let's actually just I'm actually thinking I want to reset this. I'll just come back and redo that again later. Okay, so because what I'm thinking of doing is I'll probably have a folder and then put each system in its own file, which will make it a little bit easier to a little bit easier to manage, I think. And not too many systems all in one file where I have to scroll everywhere. All right, so let's start with, we create a world. We have our bird mesh, which I have plans for also to how to store that maybe slightly differently. But let's not worry about that right now. Let's try to get a single bird on the screen. And also you are, yeah, right. This draw system, you're going to be upset. Right, so now you're just yelling at us because we're not using it. That's fine. Let's not worry about that too much. Okay, let's create a bird. Let's create our first bird. So that's going to be world dot spawn entity with component. The name of this component is going to be location. Right now, my entities don't need a string. I think that's going to be fine. We'll see. So if I want components, import you. We're going to create a vector 2D. Let's just put this somewhere like 50.0, 50.0, like that. So it's just going to have a location, and that's all we're going to care about. Now we're going to need that system in order to display it really quickly. So what I want to do is create a new folder and do systems. And inside of that, create a mod.rs. I don't know if I need like a mod.rs, or can I just do a draw, like draw birds .rs. And then in here, we're going to do a mod systems, because I don't think I can do something like systems / draw birds. I think I have to do like mod systems, like that. We're going to have a mod.rs. Yeah, okay, so then this will have to be like a pub. Now we can create our system for this. So this would be like a pub function, draw birds, system. And what would we need to take in? So we do know that we're going to need a context. The GGEZ context. We do know that we're going to need that mesh. This can be a reference to a GGEZ mesh. And we do know that we're going to need a reference to the world. We're not going to need to take ownership of it. And we don't need mutable ownership of it either. So we just need the world. And we're going to return a game result. And then we're going to do our draw here. So the first thing that we're going to need to do here is query for the locations, and then draw them out using GGEZ's draw method. Okay. So this is now where we need a query. Let's head back. Oh, we should return an okay for right now. That will make you happy. We'll come back to our library. We have this mod systems. We have all of these in place. Are you saying that you're not being used? Oh, bird met. Okay, interesting. So then in here, I want to just call this function, sort of get it going. So this is going to be our draw birds system. We pass the context. This is going to be a reference to self.birdmesh, and this is going to be a reference to self.world. We're going to question mark that. Okay, so that makes you happy. We don't need you. I don't know why we had self in there. That felt a bit odd. Drop birds. Right, you're just yelling this because you're not using you right this second. Don't worry. We'll be back. Nor you. What error are you saying that I have? Everything's open. I have a red dot here saying that there's some kind of error in here. Unresolved import. Mod systems? I have that right here. That should be the mod. Huh. Okay. How about we restart the server again? That often fixes all of our problems. It often fixes all of our VS Code problems. There we go. Okay. Now we're happy there. It's just telling me I've misspelled 10 things, but that's fine. Let's figure out our query. 50% of the time it works every time. I know it won't fix my coding problems, but it will fix like VS Code thinking that I haven't coded anything. Okay, so we need to query for the data. So I'm going to come in here to data. Oh, hello. Hi. Are you gonna go hang out by the heater? Yeah? Okay. You don't wanna be picked up and pet in front of the camera? Yeah, as I said, I've got a heater on behind the green screen, and so Zilby, the stream cat, is much more happy to go lie down and stare at the green screen as it sort of waves back and forth in the because the other heater is on too, and it's causing little ruffles. Okay, so queries. How do I want to query out of this? Let's like sort of start recreating this. Now that we're storing our data in a different way, it might be a little bit interesting. The cat behind the man. Yeah, absolutely. Oh, and he's gone. Now I don't know where he is. Okay, so let's do another test here. So how do I want to do this? I want to do a function test, querying immutably for data, essentially. Okay, so let's mute data. Oops. Data new. Let's create a location and insert that in. Let's let a location is equal to component vector 2 start at 0 10.0. Then we're going to insert this in. Let's even do this like let x equals 0.0, y equals 10.0. Then I don't even have like semi-magic. This is just x and y here, so I can compare against these later. We're gonna the name of this is going to be component name. It's going to be equal to location. Then we're going to insert this in. So our component name and our location. Okay, so that goes in. Now I want to query this out. So I want to essentially do like data, let all the locations. So I want all the locations equal to, and like what type do I want this to be? I want you to be a type of a reference to a vec of component. So I want like a data.query. I think we're gonna have to like pass in the component name. And then that should probably be it. Like that's just gonna give us either an empty vector if it doesn't exist, or this component, like the components if it does. Okay, so let's add this query. Let's create this query in here. Okay, so we're gonna be, excuse me just one second. All right, I'm back. Let's see. We're gonna get that component name that we're passing in here. So it's really just the name, which is Esther, and we're gonna return a vector of component. But it's not just a vector, it's a reference to a vector. All right, so let's figure this out. We're gonna do a self.data.get. It's a reference to the key, so that's gonna be the name. Now this returns an option. I wonder, should I just return an option with the value, with like the reference to the value in it? That might make more sense. Or, because I can then do unwrap or. So returns that contain some value or provided default. We could just do or default, which will then just be the empty vector. Maybe. Or VS Code won't tell me. Okay, it's not VS Code. And in that case, I think that was that is Rust Analyzer not telling me the right thing. So unwrap or allows me to do a function. I think I can just do unwrap or. And I can do that. Oh, but it would be a reference to this. Oh, I see. Okay. And then that would be a problem. So this probably would be best to do as just an option. I either get none if nothing is found. So let's change this around. Let's do an option. And if we find something, we're going to get a reference to a vec of component. And this allows me to just wrap around this get, just like this. Now, if we come back down to here, we're going to be this is going to be slightly different now. So we can just do an if let sum don't know if I want to do an if let sum with that. Well, actually, wait. It means that it has to return a... This is going to have to return an option. So it forces that. However, if I do this, the assert is not going to be necessarily like always called, because if I return a none, that would potentially pass to. I could panic in the else. That would certainly cause the test to fail. Feels like that's not exactly right. Let's say I do this for right now, and then we'll think about better ways to do it after. So we get the components. This is going to be like the locations. Equals, it's going to be data.query for the component name. So it's going to give us a reference to the vector of components. So I care about getting like the first one of these components is the same component that I have. So we're going to assert matches. It's going to be locations of position 0. And then our, like what we're going after. So we know this is a component. So you're going to be a component vector 2 vector 2 if vector 2.x is equal to x and vector 2.y is equal to y. Okay, so I can do that. Maybe? Yes, I can. Okay, so that should make you happy there. And then I don't like this, but we could definitely panic. We need to find locations. So if I don't find the locations, it should panic, and that will obviously cause the test to fail. So if I run this test, okay, it passes, it's happy. So that gives us, this gives us our locations. Okay, so back to our draw birds. We're gonna query the locations out of this. And so this probably is going to be an if let. So if let some. Now right now, all I care about is locations. Locations is equal to. It's going to be the world dot. Oh, but I can't just do the query yet. We're not there yet. We need to tell the world that we can query now. So we can do pub function query itself. This is going to be the component name option with a vec with a reference to a vec of component. Self.data, query, component name. And that's what we return. So it just sort of like passes through. Okay, so back to you again. World.query. The component name, in this case, we care about the location. And so now we have this reference to a vector of components or nothing at all. So what I'm thinking is if we do the else, we have this okay here. In here, we're going to do a graphics draw, hand it this context, hand it this mesh, do some draw param default. We do need to send it. Excuse me 1 second. Hey, what's up? All right. Let's see. Default, and then we're going to give it a destination of the location. Now the location. Okay, so hold on. We can't do this yet. We have to loop through all the locations, and then that's all the birds are here. So like we're just like moving the we're just like drawing circles where the location is. So what is that going to look like? That's going to be we loop through the locations. So for this could probably be a try for each. So we can do a locations dot iter try for each. We'll have our function here, which is a location. And let's multi-line this because it's going to be a little bit simpler. So we want to now, okay, so it's a component, so we need to extract it from location. Like to tell it what the component is going to be. Because it doesn't actually know that it's a location. And to extract, so it's really components here. And then we have a single component. And then what I want to do is extract the location from this component. So we could just do an if let. I think that's going to make the most sense. So if let, there's going to be a component. Oh, because it's a vector too. I wonder if I should have like a method on component here to like extract the data, like the raw data. So in this case, like if it's a vector 2, I want to like get that out. I want to get like the X and the Y. So would this make sense to me have like a get I mean, it could be an option. So in that case, this would change this assert now. What if I did something like this? Actually, you know what? I kind of like them being separate tests. So, although we would test the same thing. I don't know how I'm gonna like this. So if I have this location, it's a component, and I want to extract the data out as like a simple array. I want to like get vector 2, like get the vector 2. The problem, well, okay, I know that it's a vector 2 that I put into it. So maybe my code is aware of that part of it. It doesn't know how the vector 2 beyond that is stored. We just know that I stored like the vector 2 in. So if I do something like a get out, so let if we do something like get, like this. Maybe we even have this as like a get vector 2. This is gonna have to be an option, because what if it's not a vector 2 type? What if it's something else? But in the option, we can have this just be a plain, just very simple array, which is going to be an F32 size 2 with the X and Y. The reason why the array is really nice here is that's compatible with Mint, and that's going to be compatible with GGEZ. If it's, well, let me think about it. No, I kind of want it to be the full vector, don't I? So it's going to be the vector 2 with F32 inside. So then here we can do a if let self vector 2. This is gonna be just our data. So if that is equal to self, then I want to return a sum vector 2. The other thing is I want this to be a reference to it, so we don't take ownership of it. I think that's right, because this is a reference right there. Else a none. And I know it's an irrefutable if let pattern. I think I just have to allow this for right now. So we're going to do a get vector 2 that gives us this option. So we're going to unwrap it, which gives us the reference to this matrix. So now we can assert that vector2.x is equal to 50.0 and vector2.y equal to 25.0. So that's one way to get this data out. I don't know how happy with this I am. Okay, so back to here. So we get this component. We're going to try for each of it. We have the component. Let's now get out. So if let sum, this is going to be a location is equal to a component dot get vector2. So now we have a location is a vector2. Now, if we have an else, we have to return okay like this. But if we're in here, we can do our graphics draw. Graphics draw, hand it the context, hand it the mesh. And then we do our draw param, default.dest. And then we're going to give it the location, an array of location.x, location.y. There's something called. So this is returned out of here. Return expression. Okay, so which one is not returning properly? So we have this if to else. So you're returning to here. We have like several if else's. That's fun. Oh, hold on. There we go. Didn't need the question mark. Let's see if this works. Let's see if we've got like a circle where the bird is supposed to be. Have to recompile the BB ECS, which also includes an algebra now. It's recompiling like, each day. I know it recompiled for the BB ECS, but this is a different folder, so it's going to be slightly different now. We're almost there. Okay, there we go. And so here is our bird. Hello, Arctic Space Fox. Yeah, it's great to see you too. How are you doing? I saw that you were streaming the last few days. I didn't get a chance to watch, but I saw you so doing that. Ooh, raid incoming. Ooh, who's raiding? Is it you? Are you streaming and raiding? Rise Tech. Ooh, I don't know if I've watched Rise Tech too much. A new Rustation. Oh, awesome! I love like people discovering Rust and playing around with it. All right. Well, I'll wait. When that happens, it'll happen. Okay, let's add a new bird. He's doing the easy Rust tutorial. I don't think I've done that tutorial. I don't know if that tutorial existed when I started. Let's create a second bird here. So the way this would work is I would now say, okay, world dot spawn entity with component. It's gonna have a location and a component. Create vector2. Oh, absolutely. We're totally gonna play the game. Yeah, definitely. We'll play the game. We'll play the game when the raid comes in. All right. So let's do 150.0 and 150.0. So it's gonna be diagonal down right. nothing else changes, I should be able to cargo run this, and there it is, our second location there. So we're able to have like as many birds as we want on the screen now. So that's great. And Rise Tech rating with a party of 5. Welcome, welcome, welcome. Awesome to have you here. Rise Tech, how's your stream? What are we working on? Let's play the game. I've got it. I've got it. Cargo run release. All right, so we do have this game here. We like to play it when we get rated. It's called the Get the Streamer game. It's actually written in Rust, and we wrote it live on stream a while ago. You'll use chat commands to do it, and I'll try to chat with you all and avoid all of your stuff while at the same time. So Rise Tech, yeah, what are you working on? How are things going? You can't do multiple commands at the same time. Sorry. Chantilly's got it. And then I'll try to avoid you for 2 minutes. You're checking out Rust at the moment. It's your fully first English stream. You're so excited and terrified, but it turned out great. Oh, that's perfect. That's awesome. So I guess like welcome to English streaming and Rust. It's great to have you here. Do you normally stream in a different language? Or is this like your first stream? Ah, a heart. I'll take it. Oh, I almost got hit by that sword. I wasn't paying attention. Okay, we're getting more people. Oh, okay. You know what? No, stop. Run away. I had so much health. Like the corner is nice. Ah, no, right click somewhere else. Oh, I had so close. I was so close. But you all won. So thank you again, Rise Tech, for the raid. Yeah, this is a fun, like, I'm surprised at how fun it actually is to play, and like also to like, you know, as like a little reset every time we get streamed. So I am happy to play it every time we get rated. All right, so we got our locations coming in. That's fine. Now the really important part, we need to be able to mutably query the components so that we can update the location with a velocity. So for example here, I can let's do this. We're gonna do with a component. The name we're gonna give this is a velocity component, create a vector 2D, and we're gonna say 0.5, 0.5. So it's gonna be going down and to the right. Oh, that's the reason. We can't have that there. There we go. So I mean, it's easy. Like, I don't have to do anything else. We now have location and velocity in the system, but we have to use that velocity, which means in our library here, we have to create another system. This is going to be a new file here. This is going to be the update locations. like that. All right, so what is this going to look like? So we're going to say, okay, so we need to update all of the birds' locations. We'll do this by mutably querying for the velocities. Well, I guess locations and velocities. Velocities don't need to be queried mutably. Just the locations. And then add the velocities to the locations. So that's all we need to do for this. Yeah, it's simple. Okay, so this is going to be a pub function, update bird. We can just do like update locations system. So we know we need, okay, so in this case, we need a the world, but a mutable world. So this is going to be a world, and you're going to be a mutable reference to the world. I don't know what else I need at this point in time. Arctic Space Foss asked, technical question, what makes the Rust compiler so special? I think, so like what most people really like about Rust is the protections it offers. And that there's a couple levels of like protections there. It's a super strong type system. So there's that, like a very strong type system. Something else that the Rust team has done that I really like is they try to have the compiler's error messages almost be like a pair programmer, which is really interesting. So like the Rust compiler is actually trying to give you hints in English or whatever language you're programming in. I've never tested another language, so I don't know how good it is in other languages. But in English, at least, it's really good. Like, hey, you screwed up this, but here is my best guess of how to fix it. So it's like a pair programmer. I think they actually call it like a tutor. Like it's your tutor. And then the last piece that people, this is more of like a love-hate relationship, is the is basically enforcing memory safety, because there's no garbage compiler, there's no garbage collector in Rust, but you can almost sort of say that there's like a static garbage collection happening. Basically, here, if I finish writing this function here, update location system world, I don't know if we're going to return anything. So if I do like if we create a variable, let something equals 55. So we can see that this is an I32. I don't ever have to ever have to like get like, call memory to say like, hey, I need a place in memory for this thing. I also don't need to ever tell that I'm dropping that memory. As soon as I hit this closed bracket, this closed block here, something is out of scope. But in order to like really truly be safe at compile time for this, I can't use something twice. So they have this like entire ownership system. So that's what makes the Rust compiler so special. I don't think it's truly unique to Rust. I think there's other ownership systems out there, but I just don't know what they are. I know like some other languages have toyed with adding them in, but I've read articles about like how it would be very hard for the like what is this? Apple's new language has toyed with the idea of adding in a borrow checker. What was that? What was that language? Swift. Like Swift has thought about it. I don't know if they're ever going to do it. It would have to be like a full new version because it would break all the existing code. But yeah, so I can do like a drop something. Like I could drop this here. How do I do drop? I never have to do it. Oh, I could drop. Is it a function? Drop something like that. And then if I try to use it, like if I want to just like print line something. This should yell at me saying, hey, oh, does it not? Yeah, so calls to standard memory drop with a value that implements copy. Dropping a copy leaves the original intact. Okay, so this is actually yelling at me saying, hey, you're dropping something, but we just copied something, and so now we have two copies of it. So this isn't really the best example because of reasons. So it's interesting because of I'm dropping something, it created a copy of something in memory. So there's two of them and then dropped it. It's completely useless. Who cares about that? Now, let's say I created like a different structure like that velocity. Like let's do that. So let's do a component, create a vector 2. It doesn't matter what I put in here. I don't implement copy for this. So now if I drop this, it's now saying, hey, oh, fine. Okay, doesn't implement display. Let's do borrow of move value something. Value borrowed here after move. So what I did was I drop it and it's gone. But instead of having to manually call drop, I could just wrap this in a block here. And exactly the same thing. We create something inside of a block. At the end of the block, it gets dropped and removed from memory. So almost like it's garbage collected. And it's not available to me here. That's sort of like one of the special things about Rust compiler. It's definitely also something that causes a lot of causes people to like both love and hate the compiler at the same time, and it's fine. I hope that answers your question. Sort of like a longer answer, at least for that last one. Okay, so update location system. We need to mutably query. Well, okay, we know how to query for the locations, the velocities. We can get that separate. So we can do let what would this be? This is going to be we want to get the velocities. They don't have, they could be read only. So what if I do that? What if I do I can do let components equals world dot query velocity. So I can do that. That gives me this option with components. Okay, this kind of sucks here. Because now I have an option. I could unwrap it. And that gives me the vector. Unwrapping kind of sucks in this case. Now, I know it should exist because we entered it in earlier. So like there should never, like this should not cause a problem. We could convert this into a result and then question mark it and then return the result. That's another option for us to do. we could change the query so that way it always returns a vector of component, and so it just might be an empty vector of these components. That might be good. I kind of like that. I kind of like the idea of changing the query, but I also kind of like the idea of querying for multiple things. Like, what if I want to query for like 2 components at the same time, like velocities and locations? So let's do query mute and have query mute be more of like a query mute all. We can maybe refactor query to just be like a singular too. Let's come back into data. Let's figure this out. So querying mutably for multiple components. So mute data, close data new. Okay, so we create a new data. Let's create a couple different components here. So we can do let, we can have a location, create vector 2D, and this will be a 0.0, 0.0. We'll create a velocity, create vector 2D. We'll do this as like 1.0, 2.0. It doesn't really matter as long as they're different from each other. That'll be fine. Then we want to insert both of these in. Do data.insert. We have a location, and that's going to be a location. Then we're going to have a velocity and the velocity. Okay, now I want to query out and get both of them, and I would love to just get vectors out. Maybe a tuple of these vectors. No, because if I want to query for like as many as I want, I should probably use a vector in with names of them, and I gotta get a vector out. Or I can use a hash map. Either of those works. So let's do like our result. So our result. So what would that be? That would be like all the different components. No, I like query results. We'll just do that right now. Data.query mute. And then I want to pass in a vector. I want location. I want velocity. That's what I want. And getting back, what I want this to be is a vector of vectors. So we want to have a vec, and then I want a vector of locations and a vector of velocities. So that's going to be a vector so just a vector of component. That's really what this is. It's a vector of components, and this is mute. So I should get like a new vector, but inside of here, it should be a mutable reference to the vector of components. I think that's what we want here. So, okay, query mute. Let's create that. Okay, so we're going to take mute self, and we're going to have a query, which is going to be a vec of component names. So it's really going to be the stir. We're going to return a vec of mutable reference to a vec of component. Okay. Now it's going to yell at us that we're not actually doing that. So what I think we need to do is first start with like results equals a new vector. And we're going to return results. So that should make us happy here. Now it's obviously telling us that we're not using this yet, but that's okay. So we can write the next part of our test now. We're testing for, we're trying to get location and velocity out that we put in. So there's a couple things that we can test for. We could test that we got a length of 2. So assert equal that crew results dot length is 2. Okay. Right now, this should fail because we got a length of 1. Okay, so how do I want to do this? I want to loop through the query and get the data from, well, data. It's kind of self-explanatory. So let's loop through this query. So we're going to do query.iter. Going to do a for each. That's going to give us the, should maybe name this like queries, so we can get, oh, it's going to be like the component names. So it's really just the names. So component names there, and then here we're going to get component name. So it's this string. It's a little bit odd. It's this double reference. That should be fine. It should auto. We should be able to like get into it to get the value at it anyways. Then we want to grab. So let's multi-line this to make it easier. We can maybe single line it later. Instead of data, we want to do a get on this specific component. So what is that going to be? We're going to do a self.data.get mute based on a key, which is this component name. And what does that give me? So that gives me this option, but I have the mutable vector of components inside. So if we do a okay or, and then just a vec like that. Oh, that turns into a result. I don't want that. Unwrap or. That's what I want. Okay, so now I get this result, which is going to be this mutable vector of component, empty, or with the components that we're looking for. So I can take this result and push it into the results here. I also know that the order that they're coming in is can be exactly the same order that I want here because it's a vector. So instead of this, we're going to take results.push. Where are you in there? I kind of like having this multi-lined here because it's long. All right, now what are you upset about? Let's see. The trait bound string borrow is not satisfied. String as borrow. Okay, so what's going on here? So it wants this to be like I can't create a brand new vector. Oh, so I wonder, do I want this to be... I probably don't want this to be a mutable reference here. I probably want something like this. A vector of, like, vectors of mutable components. I think that's what I'm gonna want here. So if I do that, oh, I don't think I'm gonna do this because it's gonna die before the end. I wonder if we do have to do these as options then. Like, hey, we found none. I might have to. Okay, so get mute here. Okay, so the key is a reference to Q, but component name, I have to destructure this, or structure? Dereference it. That's all I have to do there. Okay, so results. The problem is there's still a mutable reference to a vector. So that's another problem. It's like, I don't think I can do the results push at this point in time yet. It's like, let results equals, because I have this mutable reference of the component. I think what I still need to do is loop through this and then throw that into results. So basically take in a probably do something like, okay, let results equal to a new vector. Make this mutable. I want to take this. So instead of like assigning this to results, we're going to then, okay, and we unwrap or, so we get the empty vector here. Then I want to for each through this. And then grab the results. Oh, and then mutably put them into here. So we have to iterate this. So itermute. Then we're going to for each this. We're going to get a component. It's a mutable reference to a component. I can get rid of this results now. And I want to take this component and push it into results. So results, push component. Like that. And then we're going to take, after all this is done, we're going to take results. Now, this is a problem. Results and results, I'm losing the name. So these are going to be the components. So results, that push, components, like that. So now what we see is your vector of mute components. Well, okay, this is a vector unknown. Oh, I don't want a results push. I want to components push. There you go. Now I have a vector of mute components. So it's either going to be empty or it's going to be like filled with those components. That might work. Okay, so you're got the wrong type here. So we have a vec of mutable reference to components. We should have location and velocity here. Okay, so more testing that we can do. What are you upset about? Where? Oh, get mute. Okay. What do I have? Component, what type? Okay, so you're a double reference. So if I do that, you're still upset because you're this double reference here. I don't want to do like an as ref. That doesn't. Oh, okay, hold on. Cannot infer an appropriate lifetime for autoref due to conflicting requirements. Expected standard vec. Oh, this is lovely. Expected this thing, found the exact thing that we're expecting. Thank you. I was just going by of like how the compiler is good with error messages, and this one is like not that great. Okay. First, the lifetime cannot outlive the lifetime, as defined on the body, so that closure can access self. But the lifetime must be valid for the anonymous lifetime defined on the method body. I wonder if it's this one. Like I wonder if it's actually this problem right here. I'm creating this like new vector here, and let's see. So if I do let just like, I don't know, just an empty vector. And we throw you in here. That vector dies after query mute is called. Yeah, I know. Let's see. That vector dies. You're right. It's going to die here. I don't know if I'm going to be able to get away with... This will also not work. You're right. Because like it's going to be GOI. It's going to be garbage collected essentially as soon as it goes out of scope here. I think I'm going to have to do options. I don't see a way around it. I think I'm going to have to do an option. It's like this. We're going to have the vector of option. And it's here. It'll be another vector. Either you need to pass from params or leak using box. Yeah. I mean, we could do param, so we like pass in a vector and it mutates that. Like that's another possibility. I don't like it. So if I do something like this, we have a vector and then it's going to be options. Like if we find you. So if we do something like this, I think in a way this might be a little bit more simple. I don't need this vector here. We're going to have our results. we're gonna for each. I wonder if I can map at this point in time. Oh, I bet I can. I bet we can do a self.data dot. No, okay. We're gonna do component names. Component names, we need to iter. I don't need to mutably iter. So iter, we're going to map. Inside this map, we're gonna have the component name. And then we're gonna do a self.data dot, we need to query, so we need to get mute and pass it the component name. Why not into iter? Yeah, I could into it too. In this case, it doesn't really matter. I could give ownership of this. Now, you're yelling because you're going to return expected evac option. Oh, then we have to collect. Not clone. Collect. And okay, so component name is mesh types found. Hold on. You're fine there. That. Collect. You're gonna tell me that you can't figure out what you collect into, aren't you? A value of type standard vac option. Your component cannot be built. Oh, right, because in this case, we're now back to this. Like that. Same lifetime problem. Expected. Okay, so standard vac option mute. Myself shouldn't be dropping. And I want a mutable reference into the like into the data. Yeah, I have a lifetime mistake, but where do I have to assign the lifetime? Cannot infer an appropriate lifetime for autoref due to conflicting requirements. Oh yeah, I guess I could just give it a lifetime here. So there is that. I think it's. Oh wait, it's here. This lifetime, not this lifetime. Interesting. Okay. That? No. Component names, vec of A. Oh, like this. And in return type. Okay. Like that. So I don't do you here. No, it still doesn't like this. Let's actually see if we can get the full error message. Okay, so here it is. What? No! Sure, Shock. I'm sorry about that. Let me find out what link you try to post. It's probably illegal. What? Okay, hold on. You asked, what does self.data.getMute gives? Nightbot. Links, options. Yeah, self.data.getMute is totally fine. I'm sorry about that. Especially like in this type of code where it's like, should open up, you know what should do is open up, nope, Discord over here. And then we could share like links that way. Okay, is it related to self or components? Yeah, so self.data is a hash map. So get mute is getting mute from the hash map. So I wonder if here is, okay, so I wonder if the problem isn't lifetime here, but lifetime here. So I don't need to create it here. What if here, can I do this? A stir. I don't know how to do return type for this. Sorry, 8. Yeah, that doesn't make sense. I don't know how to do lifetimes in these. This doesn't make sense. I suppose that I could try. All right, let's just try doing this without the map. Then we can come back to it if necessary. So if I were to do this like manually, you think you should give a lifetime to self? Oh, okay. So hold on, we need to give a lifetime to self. So what would that be? That would be, we give the A lifetime, and we do A is self. And it is that as part of the return. It's not happy there. Yes, okay. Interesting. Okay, so we give a self coming in. How do you just give like everybody gets a lifetime? How do I don't think I can like tell it the lifetime there. How do I tell it the lifetime as a return of the closure? Oh, do I have to do something like this? Return type. Okay, so the return type is this entire thing. Okay, so it's this map. Hold on. I'd love to be able to copy this. So it's a map into iter mute stir unknown. Cool. what are we returning here? We have this component name. Oh, so I probably have to do. Yeah, yeah, absolutely. Here's this function we're trying to do. Fact. Here's this entire page. Let's go to play Rust. I think that's right. I don't know if that allows you to. Yeah, I think that allows you to play with it. There's a lot of like external stuff in like the use, so that's obviously not going to work. Like I don't have components in here. So return type. If I'm mapping, interesting. So let's say I don't do this like collect. If I'm able to control the return type from this, oh, I don't know if this is going to be a good idea. What does map need? That maybe we should actually go look at the documentation for map. Map returns a map of self and app. But what does this function return? It returns whatever this thing is going to be. So I don't need to care about what map returns. I care about what my function returns. And so get mute is going to return this option. So it's an option of a mutable reference to a vector of component. That's what it's going to return. And so here we can say we have an A, we have a type. This is going to be a stir. And then I think we have to multi-line this. And then we're going to return, okay, that. Okay, mismatch types, expected struct. So we map. So there's that one. So now we're going to collect. Okay, so map, what are you yelling about? Type mismatch and closure arguments, expected signature of function mute stir. Okay, so mute stir. Okay. Ah, okay, so same problem. Cannot for an appropriate lifetime. Now what I was hoping is I can give the lifetime in the return here and here. Oh, I wonder if I need like a different lifetime. Oh, you're unhappy with this. Use of undeclared. How do I declare a lifetime inside of a closure? Data 10. Oh, 25. Okay, so you're thinking that I should do. Okay, so no. Oh, I wonder then if I don't need to do this, we could just have you be mute stir. But then here we have our lifetime of A. So we declare A, we go through A here. Still cannot defer. Okay, so lifetime. Now, if I just do an iter, and you're destructured here. No, still can't infer. Okay, so okay, so cargo build. Okay, so self data get mute, and the component name, the lifetime cannot live, lifetime underscore, which is just like an anonymous, like figure it out lifetime. As defined on the body at 31, line 31. So on line 31, a lifetime is defined here. Even though we don't directly define it, it's defined here. Is it thinking that component name doesn't live long enough? Like what is not living long enough? That's what I'm. So that closure can access self. Now I'm getting a mutable reference to self. And I'm not consuming self at any point in time. I wonder if I, as mute ref. I mean, I could borrow mute. I mean, that doesn't seem right. Okay, now we just move the problem over to here. So, I mean, this is where the issue is, clearly. Like, getting something from self is a problem. Let's see. So there's borrow mute. What else is there? I mean, there's dearf mute. I can't imagine that's right. Yeah, exactly the same problem here. I don't think I can do something like that to say, hey, just like mutably get a reference to this. Oh, interesting. Okay. We're returning. You're right. I don't want to return a. Okay, let. So if I do that, we get you. Are you happy? You're happy here. And if I return A, no, okay, so back to the same problem here. So it's not like I need to do this in multiple lines, which I've run into it a few times in the past, but it's the same problem where like self is getting consumed for some reason. Or at least it thinks that it is. But if the compiler is saying it, I'm pretty apt to believe the compiler. Self is probably getting consumed in some way, somehow. Why? Like, why are you unable to believe that this is not going to go away? Now, so this component name, let's see, what are the different methods that I can tell for because I'm borrowing, okay, so for this component name, I'm borrowing from you to get the component names and then go for self for here. I don't want to do something like move. That seems like then it really would be killed. Let me try, okay, so in the interest of just moving on, let's try doing this without lifetimes. If I were to try to do this just with like normal for loops, I wonder if it'd be easier. So I want to loop through all the component names. So for component name in component names. So now I have this vector of stirs. Okay. Did I do that wrong? Did I like have mutable reference? No, okay. So that was okay. So we have component name and component name. So we have this, we have the component name. Now I want to get it's like let results. This is going to be the components equal to self.data.getMute component name. This gives me the option with immutable reference to the vector of component, which is this part. Then I want to let results equals a new vector. I'm going to make you mutable. I want to push you in. And I want to return and give ownership back to the caller, the results. Here we go. Cannot borrow self-data is mutable more than once at a time. So I'm not trying to, but the problem here, I don't know how to do multiple queries all at once. I guess like that's a problem. So I can't do multiple queries at the same time. Hey. because now I'm going to have multiple. Yeah, I'm going to have some kind of multiple references here in results at the same time, which kind of sucks. Okay, so self data. Is there something else that I can use? So I can do let components self dot data dot what, like what else is there, like some kind of like get mute multiple? I mean, maybe I can do iter mute and do it backwards. Like do this in the opposite direction. Match? Interesting. Let's see, we could immediately borrow from our own value. So if we have this new vector, check is T of type borrow mute. Interesting. I think that happens behind the scenes automatically, so I don't think I need to worry about that myself. The query builder might be interesting. Like the query builder method, like a builder pattern for it might be interesting to do. It's like create a new query for this. So what if I did something like hub function, like query mute. Well, it immediately has like problems with this. It would have to be, this unfortunately would have to, well, okay, no, we could return a query, like a different struct, as Shurshock was saying. We could return a different structure that could then like add the queries together, and it builds the return vector as we're going along. I wonder if that would work, because then we're only doing one at a time. So I think we had like a query that we were building out for this. If we start over this, because I'm not using this right now. So if I have something like a pub struct query. Now I don't know what to like store in this. I guess it would be like the results, right? So we have the results is going to be a vector of component, and that's pretty much that, right? So if we have query mute, I wonder if then gonna want like a query mute. And in here, we're going to mod query. So in query mute, we're going to take in a mutable reference to self and a vector of name. So component. Well, I guess I wouldn't take anything like this. I would take query mute, and this is it. In fact, I don't even need a mutable reference to self. I just need like a reference to self, and we're going to return a new query mute. And so query mute. I'm going to be pretty simple. Guess we could just do self. Here's a new vector like that. We do need to pull you in. Then in here, we're going to return query mute default. So if we do something like this, we now give ownership of query mute to whoever calls it. But then we're going to have like another function or as part of this query, so we can then add like the data to the query. So so we have like create, like we start the query and then with component essentially, which kind of sucks because query mute. I guess like I'm trying to think of like how this is gonna look. Let's go down here and take a look. So we have results. We're gonna do data dot query mute, then something like dot, and then like for component. Location, something like that, and then another one dot for component velocity. Okay, so if we do that, then in the end we're gonna get this, but it's gonna be a query that we're getting back. So we're gonna have to like then like build the query, then like finish, like query for it. I'm not sure. Maybe build. So we're missing four component. Now here is where I'm gonna mute self. Component name, and I want to return a I want to return this actually makes sense not to go in here. This makes sense to go in the query mute. So like we start a query mute and that returns this new query mute. We go into query mute here, and now we have a impl query mute pub function we see here that we're caring about this for component. Chet Dev, hello. Yeah, I know, still going. How are you doing, Chad? I saw you were streaming the other day. You streamed with CJ. Ooh, hold on just 1 second. Oh, you need to erase this.
Oh. And then does it install the latest OS?
If it doesn't install this, so this will get.
Okay, okay.
It's this. Because it's valid.
Okay, thank you. Oh, okay. Yeah. Should I encrypt it or no?
I would recommend once you get yours going. More safety.
Okay,
Love you. Okay, I'm back. You need Musean to solve that issue? Yeah, I've seen Musean streaming every once in a while, but I haven't seen Musean around my stream in a bit. Okay. But yeah, Musean does know a ton. Ooh, good drop. Okay, so we have this like for component. We're gonna take a mutable reference to self. Now, how do I get the data? I guess we're gonna need the data passed in here too. Seems because I won't be able, like, I need to be able to search for this specific data. So that's a little bit unfortunate. Like, so I could have like the data comes in, which is type data, and I really just want you to be like a mutable reference to the data. And I also need the component name. So in this case, for the context for component, it's the name, just a str. And then we're going to return a mutable reference to self, so that it continues to build this mutable reference up. If we were to do this, I think it would work and make it a little bit easier. So results is not going to be a vec of component. It's going to be a vec of an option of mutable reference to component. I think that's what it's going to end up being. Ah, okay. So now we have a lifetime problem. So then I need something like this. And then data, you're fine. Need to pull you in. Okay, so that's all fine here. What are you upset? Okay, so you're upset because we're not actually returning the thing. So that's good so far. Where in the world is Musean? I know. With a lot of these things, let's see. What are you upset about? The lifetime of reference outlives the lifetime of borrowed content. Really? So how about this? I take in ownership of self. Oh, wait. What if I do this? Okay, there we go. Now we're happy. I've used the lifetime everywhere. Then I want to actually do the query and then stuff the thing inside. So we want to say self.results.push. It's going to be the data. So data dot data dot get mute name. So it expected option. So mute components component. Okay, so I found option of vector. Oh, you're right, because this is really another vec of component. Explicit lifetime required in the type of data. Add explicit lifetime A to the type of data. Here. Okay. So we're still happy here. This gets pushed into the resulting vector. Now this is really ugly. This is not what I would consider good, but it works. Okay, so now we have this for component. So we have query mute that gives us query mute. You can do this for component. What's your problem? Right, this component takes two. Okay, let's figure this out. We have to pass in the data. So it's a pass in the data and the name. Like that. And you need to be a mutable reference to the data. Okay, and then it's just saying, hey, we need a build to get this back. So let's take a look at what we can do in build here. So if we take build, we take a mutable reference to self, and that's it. Now we want to return a vector of vectors of mutable reference to component. I don't know if this is gonna work. I may have to just sort of like leave it exactly as it is, and then that's just what you get. But I would love to be able to convert these options to vectors here. It would be wonderful if I could do that. I am not convinced that I can though. So if I do this, I want to do a self.results. I can consume this because we're done. So into iterative. Then I want to map. And we're going to take in this like result, which is this option of mutable vector of component. So if it's good, so let's do this here. So if let some component equal to result. Then return the component, else return a new vector. And return that. Mismatch types. Okay, so expected this vector of vectors of components found this map. So then I need to collect it. If and else have incompatible types. So expected a mutable reference to the vector. Interesting. Okay, so we have a mutable reference to a vector. What I really want, I wonder if I can do this. Like let mut results equals like a new vector here. Can I like push in what we have of the components? Oh, there's a way to do this. There is a way to easily move in this. What is it? Component dot leak, maybe? No, okay, so that's wrong. That's not giving me, that's giving me like an array. So leak is not it. I want to sort them. No, as mute doesn't give me it. Yeah, so I don't know how to get this unless it's like somewhere in here. Like maybe it's not part of this. But basically what I want to have happen is I want a vector, and then the component is a mutable reference. What I'm getting here is a mutable reference to the vector. So I guess like not best result here is hold on. If we have a component, it's this mutable reference to the vector, I need to loop through the vector and get the components out. But components is equal to new vector, return to components. Cannot move out of self results, which is behind a mutable reference. Right, I don't want to copy the component. Apoc Sama, hello. I'm trying to, so this entire thing is I'm trying to query mutably for something. Like I'm trying to mutably query for the values in a hash map. So if I was to come to the playground and sort of reset this, actually, this is the wrong one to reset. Let me do a new one. There. If I did use standard collections hash map. Okay, so let's do main. Data is equal to, gonna have a hash map of, say, like a string and something. So, I mean, I don't know if it matters too much at this point in time. Let's just do like an I32. Something like that. So that gives us, use a bit of Bevy, but investing in the new query syntax. Well, here's the thing is I'm trying to create my own ECS. So it's, I think Bevy is using like a variation of hex behind the scenes. Cause I did see like a Bevy hex crate. I didn't like look to see whether or not they're like still using it or if they're making their own. What is an ECS? It stands for Entity Component System. It's just a way of, it's a way of storing your data in like its own sort of like data structure architecture for not necessarily easy access, but like better access for like the CPU and composition over, you know, inheritance and all that fun stuff. You thought it was Bevy? Oh, that, I think that's a compliment because that means my code is like looking like a good engine, but it's definitely not. So if I have this data that's in here and I want to grab multiple things out. So let's say I insert a couple different things. We'll do data.insert. We're going to do like first to owned. And then we do like 55. I'm going to do data.insert second to owned. And then you're like 64. Now, I want to get both of those out mutably. Like mutable references to it. If I just do get, so if I do like data.get mute, so I can do let like first equals data.get mute, and I can pass in like first. This works. I can debug first, and we can see what did I miss? On line 4, function main, open, closed, new, semicolons in every line. Oh, colon here. Okay, so we see that it's an option, so I get a sum 55 here. If I want to, and not shown here is that this is a, I can basically say that what we're getting here is an option of a mutable reference to an I32. That's what we're getting. So that should compile still. If I have these be, oh, no, stop. If I have this be a vector of an I32, then we're going to insert a vec 55, a vec 64, whatever. That's fine. Now this can be a vec of I32. Okay, so still fine here, except what I really want to do is instead of having options, which I totally understand if I can't, like maybe I should just like move through it and say like, yeah, whatever, I'll just have some unwraps on here and it's gonna suck. If I could switch this to getting like in my query to not having an option, but switching it to be just a vector of mutable reference to this. I would love to figure out how to do that. And that's what I'm trying to do, is somehow query out of this hash map and do something here. Maybe probably multiple lines here to then get this out, which means it might be an empty vector. And then I can stuff those into multiple vectors and do multiple queries at the same time. But I need to like basically swap the option, convert it. Yeah, the ancient old like question profit. Yeah, exactly. Now how to do that is where the problem comes in. I think this is like at the edge of like this is past the edge of what I know with Rust. So I'm trying to figure it out. We have this get mute first. It's going to give us an option. And so I could just unwrap this. And that will give me the vector or just crash to the ground. Fine. Okay, great. Wonderful. I don't want to have to do that, but okay. So let's say I could even have a function in here. So like we could do a function like query mute. We're going to take in the data, which is this mutable reference to the hash map, which is a string and this vec of I32. Okay, so we're going to get that. And we're also going to take in like what we're querying for. So maybe we don't even care about that. Maybe we're just always going to query for first. And we're going to return this. This is what we want to return from it. We want to figure out how to return that. And so we're going to pass in a mutable reference to data. Okay, so that's fine. Now it's going to yell at us until we actually do the thing. So I want to get that out and have it not be an option anymore. So what would that look like? That would be I want a single thing out of this. Let's say we just do this one line at a time. So like let result, and it's really gonna be the option, right? So it's gonna be like maybe result. Say data.get mute, pass in first. Okay, so we know that this is now an option of with a mutable reference to vec of I32. We can do an if let sum, and then this is going to be our like the actual data that we're looking for. So it would be our like our first. Like the values is equal to maybe result. Okay, so if this exists, then we're going to get a mutable reference to a vector of I32s. Surely you shouldn't be doing that though. You don't own the I32. Well, I don't want to own the I32, although like if we just take you like this and I make you here. Well, okay. It's because in real life it's not doing that. So hold on, let's say we have this results, which is the option of these vec components. And what I really want to do is like when I build this, that's the thing is I'm not just reading it, I need to mutate them. I need to be able to mutate them, but not clone them because I need to mutate the originals. That's where I'm running into problems, is the mutable queries into the data. The immutable queries into data is easy. That's no problem whatsoever. If I'm doing this, we have a vector and then we get this mutable vector of components. I mean, we could just say, you know what? You're going to be options. In which case, I don't even need a build. Like I could just get rid of the build and we have this results. I guess, you know what? We do need build. We're getting a mutable reference to self. But we're going to return the results. So it's going to be this vec of option with mutable reference to vec component. So something like that. Then I just return self.results. And I'm okay with taking ownership of self because we're done. Okay, so we need the lifetime specifier. So if I were to do this, come back to data here, and we can say, okay, we query mute. So data, we query mute, that gives us the query mute. For component, we give it the data. What are you yelling us about? Right, okay, so I'm gonna take away the requirement for this type. Cannot move out of immutable reference. Move occurs because query mute. Do you still need to be like that? No, because then we can't move out of here. That's our problem. It's like I want to like consume and like pass ownership of this vector, but the vector has like this option of the mutable. And I don't think I can do like a toOwned on this. I don't think I want to do like a toPointer. Let's see. I don't think I could do like an owner or like take. Yeah, I don't think there's any of these that like help. Because like results, self.results is this vector of options. And I don't want to like copy all the way down. It's like that makes you technically happy there, but not here. Now I wonder if I can get away with like the original again. If we just do like query mute, and okay, so let's say I do like one at a time. If I just do like location, that's all I care about is just this location. Query mute, mute self. Actually, wait, was that the problem? I need you to be. Well, mute. No, okay, so that's still. So query mute, and we get like the location. So if I just want the location here, and we change you, you're going to be a vector of option of mutable reference to a vector of component. So in which case we're going to call a new vector. We're then going to call mute and like pass it in and like be part of this. Also name. We have component name stir in here. And so if I then say self dot data dot get mute component name, that returns this option with immutable reference in there. And then we return results. Okay, so this works. This works. Now, let's say I want you to do multiple at the same time. So I want really to have like a vector, and I want location, and I want velocity together. So it's gonna be the same thing. We're gonna have a vector of now like multiple options in here. So here we have component name. This is gonna be whatever that was. Component names, and you're gonna be a vec of stirs, like that. Okay, so now we have these results, which is this empty vector. We have it's immutable. I now need to loop through our component names and push in to the results whatever we get. So I wonder, would it make sense to map, to do component names dot into iterator. So we just consume the iterator, then we map. We're going to take in the name, and then we're going to do the self.data.getMute name, and return that result. And the problem is no expected this vector of option, a mutable reference to the vector of components found, because we need to collect. And it's this exact same problem over and over and over again. Cannot infer an appropriate lifetime due to conflicting requirements, which is out of here. And it's like, okay, so let's say I do let mute results equals a new vector. Then we just go through the component names. So let for name in component names. Now I have this string here. Can I push into the results? So results.push self.data.getMute name. And then return results. No, because we're trying to borrow self-data more than once at a time, which is not cool. We need to make sure that it lasts long enough, or like that we're not trying to do this, which I wasn't trying to. I was trying to like, okay, it goes one way through, we get the thing, and then we do that. Do we need ref cell? We might need ref cell. We might need a ref cell or a cell. Yeah. So looking at ref cell and cell, let's come over and take a look. If we go to RC, where's ref cell stuff? Oh, in here. The problem is the lifetime is inside of the closure. If you need immutability, put a cell or ref cell inside the RC. Okay, so an example of immutability inside of an RC. So here's a RC ref cell of unknown type. So we can say like in this one, Yeah, I know. It's rough. So yeah, we could do the RC. So what we're gonna do is a shared map is hash map new. Oh, interesting. They're doing it backwards. So I think we need to do, I think we do need to do this. I think we're gonna need to do ref cells and RCs. Do I need to do, okay, so do I need the RC? Can I just do ref cell? Yeah, so RC is like allows me to have mutable owners. I wonder if this would allow me to do like in data. So if it's a vec of component, it would be in here, right? It would be the RC RC ref cell? Hold on. Do I need it to be an RC? Could I just go straight to ref cell? I don't know. I could try ref cell. And then instead of this, we have our vec component. Like that. If I do that, then in here, when we push the new data, so this needs to be raw data dot deref mute. I can't remember. Mute, no, because that's not gonna get it in here. So now I have this ref cell vec. Oh, borrow mute. Okay, so I could do raw data dot borrow mute dot no, not push. You're just a mutable reference to that. So then dot deref, nope. Deref mute, nope. How do I get in? So or default and then or mute. Uh-oh. Uh-oh. Sure shock. What did it do? What did Nightbot do? What did Nightbot think that you did? Self the data that push raw data. Okay, so hold on. Let's take a look. So here I have this mute ref cell that. Okay, so I can do like raw data dot. I can't do push anymore. Like it doesn't think that that exists. No method for mute in a ref cell. Well, I can't equal stuff to data. Can't like reassign that. We could do another get mute. There we go. Okay, so now we have this. There we go. So then we do another get mute on here. Get mute. There we have the reference to there, and so now we can do data dot push the new data. Okay, so that should insert. I believe that should insert. Also, I accidentally brought in raw. Didn't want to do that. You want to do this either. Okay. So query time. Wait, did it happen again? It's like Nightbot is like, no, okay, so is the same stuff. I know it's the problem with like Nightbot is thinking that everything is a link when it's just really accessing objects or dot notation. Okay, so if I was to do a query now, like heck, let's ignore the query just for a second. Let's get everything else set up here. So insert multiple data, test querying. Not gonna worry about you for just a minute. Okay, so insert data. We do data get location. This is our ref cell. So then we have to do it doesn't even need to be get mute. It's just be get. Okay, so I think maybe that'll work. Oh, no. Okay, that won't work. Dot. Okay, get mute. Because as mutable reference to a component, let's do 0. Okay. So then down here, same thing. You're a ref cell. So then I want to dot get mute. Gives us that. Okay, so fine. We're good again. Then now we're going to go back into querying. Let's start this over again. So we're going to do pub function query mute self. We're going to take in a vec the names. And we're going to return, I don't know, something. So for this, we're going to take our component names. We're going to get them out. Okay, so let's do like for name in component names. We get our string. I'm going to do let like the result equals self dot data dot get mute name. Okay, so it gives us this option with a mute ref cell. Okay, so now if I unwrap you, like unwrap or and it's like a new vector. We now have I don't think that's going to work. We have this option here. Option with immutable ref cell. Okay, so we can do an if let sum. Get the result out equals to this. And okay, so now we have this result, which is a mutable ref cell with the vector of the component inside. So let components equals result dot get mute. Okay, so is that so now if we have like our let all results equals need this be mutable. A new vector, and we push this in. Okay, are you super upset yet? Not yet. So now it's a vector of a mutable reference to a vector of component. Okay. If this fails, if it's a none, we're going to push into all results that push just a new vector. This is the problem is it can't be, this is going to be owned vector and it's going to be a mutable reference to a vector. So that's not going to work. I would almost want to have like the ref cell inside of the vector of these. So like instead of doing a ref cell of vector like this, do a vector of ref cell of component. Like that could work too. Unfortunately, it is 12:28. I'm like way past when I wanted to end. I think I might have to like continue working on this tomorrow morning. This might work. Like doing it this way might work. So thank you, Shershok, for sacrificing yourself to Nightbot to let me know about RefCell just on its own, not with the RC, just RefCell on its own. I think it might work. We might get there. I don't know. We'll find out. It's an adventure for all of us. There's no Zilby close by, so I can't give a celebratory like pet the cat. So unfortunately, we're just gonna have to end it here. But I'm gonna switch over to the ending screen.